In this problem, we're asked to look at several different salts and to determine which, if any, would have an effect on pH when dissolved. First of all, let's note that for all of the choices, A, B, C, and D, and all of the choices within those parts, none of the positive ions are ammonium ion or derivatives of ammonium. And secondly, since they're all metals, I would note that none of the metals have a charge of 3+ or more. In fact, if we just did a quick jotting of the charges, silver's a +1, we have lead 2 ion +2, strontium's a +2, and in this case nickel's acting as a +2. So none of those metals have a charge high enough to say that it's important in determining pH. So what are we left to consider? Well, we're going to look at the anions of each of the salts. And we're going to ask ourselves, for each of those anions, first of all, is it the conjugate of a weak acid? And if it is, then it is important in determining pH. The other way that it can be important in determining pH is if it actually produces a strong base species. As we see here, this guy is a strong base itself. So when it dissolves, we have hydroxide produced. So that one definitely affects pH, much more so than any of the other salts, provided that they're of equal concentration. So given that in part B, we definitely want to check the box for lead 2 hydroxide. Let's go through the others and figure out what the conjugates are. So, okay, we've got in silver chloride, the conjugate acid is hydrochloric. And hydrochloric is a strong acid. Okay, so that means this salt is not important in determining pH. Let's look at the bromide ion. The conjugate acid of bromide ion, hydrobromic acid, is also strong. It's one of your 7 strong acids. Therefore, the salt is not important in determining pH. With silver fluoride, we have a fluoride ion whose conjugate is hydrofluoric acid. That is not one of your 7 strong acids. So for part A, that is the correct answer. And we're going to work similarly all the way down the chart. With lead 2 chloride, just to verify, we already had determined that lead 2 hydroxide is a strong base itself. And so that would be the correct box to tick. But let's just be thorough here. Our conjugate acid, if we have chloride ion, is, of course, hydrochloric. And that's one of your 7 strong acids. So that's not important. With strontium nitrite, our conjugate acid is nitrous acid, HNO2. That's a weak acid. That is important in determining pH. That's going to be the answer for part C. Let's go on to the other choice that we could have considered. The anion is nitrate. Conjugate of nitrate is nitric acid. Well, that's one of your 7 strong acids. So that strontium nitrate is not important in determining pH. Okay, Cn- is cyanide ion, so we have hydrocyanic acid. That one is weak, so it's important in determining pH. And then lastly, just like we've considered before, nitrate is the conjugate of nitric acid, which is strong, and therefore the salt that contains that ion is not important in determining pH. It's all a matter of considering the conjugates.